Okay, this is it. This is the next lab you guys are doing to see if the index of refraction of water is 1.33. The first step is to go to my website and find a couple documents. The first one is called Rectangular Tank Refraction Lab, and it looks something like this. It's got a data table and some instructions of what to do with your data. And the second document is called Rectangular Tank Tracing, and that's the piece of paper you actually collect the data on, but there's something wrong with that piece of paper. I'll show you in a second. Anyways, to set it up, you have to retrace this thing. When you take the actual rectangular tank that's going to hold the water and you set it on the tracing that you printed out off of my website, it might look like it fits, but it doesn't really fit. So you got to flip the paper over, and then you're going to actually trace the tank yourself. So if you do it carefully, it'll end up looking like a rectangle ought to look. And then you've got to get it ready for the rays that you're going to try to follow. So you make a dot over kind of on the left side of the top boundary. Should look like that. If you set a protractor down, you can make a line that's perpendicular to the tank's upper boundary. So make a dot at the 90-degree measurement, and then with a ruler, if you connect those dots, you'll have made a line that's normal to the top surface, and it'll look like this. Make the normal as a dashed line. Now you've got to make measurements. So you want to make a bunch of evenly spaced angles at increments of 10 degrees. So with a protractor you can set it up, and it's going to end up look like the thing you had on the front side, only you're going to make it yourself. So you might have a line that's set up at exactly 40 degrees, and you have to see how passing through the water affects it. So to do that, you got to fill your tank with water. Be careful not to spill it. So as not to spill, go to the sink first, turn the water on, and then put the tank under the water. If you put the tank under the water first and turn it on, it's going to splash it out of your hands. So make sure you have a low stream of water. Take the full tank back to your desk and set it back inside your tracing. And at this point, the lab's going to get kind of similar to the one that you did for the law of reflection. You have to get down to eye level and squint one eye and sight along the edge of a ruler. This time, instead of looking for a reflection, you're looking for an extension of the 40-degree line that you see through the water tank. So you draw your line along the edge of the ruler you're looking down, and it'll look like that. Or I rotated the paper, that's what it looks like. Take the tank off, and then if you set the ruler back down, you can extend the line of sight until it hits the bottom boundary of the rectangular tank. So it looks something like this, and you're just missing one little part of the ray of light as it passed through the water. So if you set the ruler down and line up the two ends of the other lines that you have, it'll show the path that light follows as it goes through the water. So you're seeing light as it refracted. You need a protractor to measure angle of refraction. You chose 40 degrees as the angle of incidence, so now measure what the angle of refraction is in the tank of water. So when I measured it, 40 degrees in the air turned into 28.5 degrees, and then on the data table I would record that, and hopefully that makes sense. That's it.